Hi, can you hear me?
Yes, ma'am.
Okay. So where we left in the last class, we were having this reaction BCl5 that goes to
Yes, ma'am.
BCl3 plus Cl2, and the oxidation number for phosphorus here was +5, for chlorine was -1. Here for phosphorus it was +3, here chlorine was -1, and here chlorine was 0. Okay, so this one here phosphorus went to +3 from +5, so it reduced. So this is reduction, and Cl-1 goes to 0 from -1. So it
Yes, ma'am.
increased. This is oxidation. Now, in the last class, we read about pump proportionation. So what is pump proportionation reaction?
It is like Na plus H2 give rise to NaH.
Not the definition. Like, can you just explain me in general terms, not with a specific example? That's what is happening here.
Comprom it's like
Huh?
no, it's like a reaction like in which we are like supposed to find out
Okay, the
reduction of
example you were saying, that was Na
Na plus H2 give rise to NaH.
gives us NaH. So Na was 0 here, H2 was 0 here Na is +1, here is -1. So what we concluded from here, Na is getting oxidized and
Yes, ma'am.
H2 is getting reduced. So here the resultant product
Ma'am,
of, yeah,
ma'am, did you went through my homework? Last night I actually posted it.
okay. I guess I
Ma'am,
have not received it.
no, ma'am. Actually, I posted on a student portal.
Okay, then I will check it.
And ma'am, one more thing. Ma'am, is it okay? Can I put again like because ma'am by mistake I just posted like one homework, like one page of
You
homework.
want to post it
Others,
again? Okay.
yes,
Post
ma'am.
it again, post it. Post it again.
Ma'am, the option is not there.
Okay. Can you please talk to the team about it? Actually, I don't know much about the technical side. I will ask them once, okay?
Okay, ma'am.
Okay, so what is comproportionation reaction? The resultant product of the redox reaction is a single product, or the resultant product of the redox reaction is same.
Yes,
You
ma'am.
see, here through the oxidation pathway it is also reaching NaH, through the reduction pathway it is also reaching NaH. Fine?
Yes, ma'am.
So when oxidation and reduction both gives the same product, that is comproportionation reaction. This
Yes.
thing we did in the last class, and today we are going to do this proportionation reaction. Okay. So the
Yes.
example we were doing, this is a disproportionation reaction. By looking at this reaction, can you try to define that what a disproportionation reaction is?
This proportionation reaction is like the resultant product of the redox reaction is a double product.
What you are saying, that
The resultant product of the redox reaction is a double product.
rather what we can say, the reagent that is taking part in the redox reaction is only one, is the same. You
Yes,
see
ma'am.
here, both the reagents were different, but they were going to a single product. Here we have a single product, and a single product is going through both reduction and oxidation and giving rise to different products. Okay,
Yes, ma'am.
you see the difference? You understood what is happening here, right?
Yes, ma'am.
Okay. So if we try to define it, this proportionation reaction, here one compound one compound of an intermediate oxidation state converts to two molecules with different oxidation states. Okay?
Yes, ma'am.
Okay. So if I give you more example here,
Now,
yeah,
can you scroll a little bit? I want to write the
okay, okay.
okay. Okay, ma'am.
Okay.
Ma'am,
Yes,
what will you name this compound NaClO?
NaClO. Let's
Yes, ma'am.
see. Okay, I'm coming to the name. Wait.
Okay.
Let's first do this. I will come to the name. Okay.
Okay.
Okay. This one. These are our four reactions. Now, what you are supposed to do, you are again, you are supposed to deduce oxidation numbers. So here you have to do it for O2. Here you have to do for the oxygen molecules. Here you have to do for chlorines.
Yes, ma'am.
Here for bromine, and here for the phosphorus atoms. Okay. If you need any kind of information, any kind of hint, just ask me.
Okay, ma'am.
So you have to determine for oxygen in the reagent site. In the first case, oxygen in the reagent site, like oxygen for reagent and both product sites. Same for
Okay.
Cl2, same for bromine, same for phosphorus. Okay.
Okay.
Okay. Consider the oxidation state for others to be the usual one. Okay.
Okay, ma'am.
Okay.
Hello, ma'am.
Is it done?
Yes, ma'am. Yeah.
So, what did you get for the reagent side of oxygen?
So for ma'am, reagent side of O2, I got -2.
How?
Because ma'am, its oxidation number is -2.
If that is -2, then what is for hydrogen?
Ma'am,
In the reagent side, I am talking about this one, okay? What did you got the oxidation number for oxygen in this compound?
amount for oxidation number, I got like for hydrogen, I had minus like +1 into 2 plus
Hmm.
1 into 2 plus into -2. So it was 2 minus 2x. Then it was it's -1.
Wait. Plus one into 2, this is for hydrogen, right?
Yes, ma'am. Yes, ma'am.
Plus 1 into 2, this is for hydrogen. And for oxygen, you considered it to be X, okay? So how many oxygen we have?
2.
We have two oxygen. So if we consider oxygen to be X and this is 0, then what is the value of X?
We got 2 plus 2x, and then 2 will go over there.
Hmm.
It will be -2. So it will be -1.
It should be -1. So this is -1, right? Not
Yes,
-2.
ma'am. Yes.
Okay. Now, what did you get for H2O?
For
For the
H2, I
oxygen in
got
H2O?
H2O. For H2, I got -2.
-2. And O2?
0.
0. Fine. Now coming to the next one, Cl2. Chlorine in Cl2 is
0.
0. Chlorine in NaCl?
NaCl
-1.
-1.
Okay. And in NaClO, chlorine is +1.
Plus.
Okay.
Yes, ma'am.
Why +1? Because oxygen is -2 and sodium is +1. So to
Yes,
make
ma'am.
the whole charge neutral, chlorine has to be +1. Okay?
Yes, ma'am.
Because all of them are in 1 in number. Okay. Then in the third one, what is the oxidation number for bromine?
For bromine, it is -1.
Uh, between bromine and fluorine, fluorine is more electronegative. So if there is a compound of bromine and fluorine will be the negative one. So in that case, what will be the oxidation number for bromine?
Yes, ma'am.
Fluorine is more electronegative than bromine, okay?
Yes, ma'am.
Okay. So if fluorine is more electronegative than bromine, so if there
Ma'am,
is a
your voice is too
compound
low.
where we have both fluorine and bromine, okay? Yeah. So if we have a compound where we have bromine and fluorine both, in that case, fluorine will have the negative charge and bromine will have the positive charge. Okay.
Okay.
So what will be the oxidation number for bromine here?
It will be
It would be
-1 +1.
+1. And fluorine here would be -1 because it is a bond between bromine and fluorine is the electronegative one. Fine.
Yes, ma'am.
Similarly, in bromine trifluoride, here we have chlorine is -1 and we have 3 into -1. And we have only one bromine, so 1 into x plus 3 into -1 is 0. That gives us the value of x is plus 3. Fine?
Yes, ma'am.
And in this case, in Br2, bromine is 0.
0.
Alright? Okay.
Yes, ma'am.
And in the fourth one, what will be the oxidation number for phosphorus in the reagent side here?
It will be 6 -6.
How?
No, it will be -12.
What?
Maybe hydrogen
Okay.
is
Please
3.
tell me the equation. Just tell me the equation first.
Hydrogen
Hydrogen
is
is
+1. So we'll write it as 1 into 3 plus
positive 1. So it is 3 into plus 1 plus
1 into x. We'll consider this as P.
mhm,
And then O will be -2 into Q.
mhm, and that gives us 0.
0.
So now solve this one and tell me what is the value of x you are getting.
Oh, it will be +1.
Yes. It will be positive 1. Here what will be the oxidation state for phosphorus?
-3.
Negative 3. Okay. And here
It will be 0.
it will be
No,
0.
answer is a +3.
No, in the third one, in this one, it is positive 3. Okay. So, can you see the pattern here now? In all the cases, so what was our definition for disproportionation reaction? It was that one compound
Of an intermediate
of
oxidation state
an intermediate oxidation state
converts
converts to two
two
molecules with
molecules with
different
different
oxidation states.
oxidation states.
Yes. So in the first example, oxygen was in -1. So from -1, one part of it goes to -2 and another part of it goes to 0. So -1 lies in the intermediate of -2 and 0, right? So we had
Yes, ma'am.
a molecule with intermediate oxidation state, and from that we got two two molecules with two different states of that specific atom. Okay. Similarly,
Yes, ma'am.
here we had 0, and from 0 it went to -1 and +1, and 0 lies in between -1 and +1. Okay.
Yes, ma'am.
Okay. Similarly, here we had bromine in +1, it went to +3, and it went to 0. So +1, it lies between 0 and 3. Fine.
Yes, ma'am.
Okay. And similarly, in the last case, we had it in 1, and then it went to -3, and it went to
0
+3. And
plus 3.
clearly, 1 lies between -3 and +3. Fine.
Yes, ma'am.
The disproportionation reaction is fine.
Yes, ma'am.
Okay. So if I ask you that what is the difference between comproportionation and disproportionation, what will be the answer?
That the answer is in that we are supposed to convert the intermediate oxidation with two molecules. And in comproposition, the resulting product of the redox reaction is a single product.
Okay. So what we can see that in the comproportionation, in the first one, the product is in the intermediate oxidation state, and in the disproportionation, the reagent is in the intermediate oxidation state. Fine?
Yes, ma'am. Yes, ma'am.
Okay. Okay. Now let me give you a question from your book. The question is, we have done it several times. Now explain me that we have this reaction, 2 sodium plus H2, and that gives us 2 NaH. Okay? This
Yes,
is the reaction. And you have to tell me, is this a redox reaction? Yes or no? And why? Okay?
yes, ma'am.
Okay. So is this a redox reaction?
Yes, ma'am.
Is this reaction a redox reaction? Yes or no?
Yes, ma'am.
Okay. Why?
Because Na is considered as reduction in which gain of oxygen take place, and for hydrogen
Na?
also is
Mm-hmm.
Na, 2Na, and in H2 it's oxidation loss of hydrogen takes place.
Okay. Good. Also, we can say from here that here the oxidation number for sodium is 0 and hydrogen is 0. And here for sodium is +1 and hydrogen is -1. So, a change in oxidation number is taking place. Right?
Yes, ma'am.
From here also we can conclude that this is a redox reaction. Because redox reaction are those reactions where the oxidation number changes, right?
Yes, ma'am.
Okay. Now, if we go through your book, there are 3 more examples of redox reactions. Those are, the first one in your book we have combination.
Second one is displacement.
Yes, first one is combination. Second one is displacement. Displacement. Then we have decomposition.
Yes, ma'am.
So if we look for example, combination, see, all of these are redox reactions. So the first criteria is the oxidation number will change. Okay, that is the primary criteria.
Yes,
And now
ma'am.
based upon that, firstly we have C plus O2 that goes to CO2.
Yes, ma'am.
Then if we take example for displacement reaction, we can see CuSO4 plus zinc. That gives
Yes,
us
ma'am.
2 plus ZnSO4. So this displacement reaction, we can say that this is equivalent to the substitution reaction we have read in organic chemistry.
Yes, ma'am.
Okay. And finally, we have decomposition reaction. And an example for decomposition. Decomposition is just the opposite of combination. Okay. So if I write CO2, this goes to C plus O2. That is decomposition reaction.
Yes.
Also, if I write 2H2O, this goes to 2H2 plus O2. This is also decomposition reaction. Okay.
Yes, ma'am.
And
Ma'am,
now similarly, here yeah.
ma'am, displacement is also another name for redox reaction, right?
Yes, you see here the oxidation number of copper was +2 and oxidation number of zinc was 0. But here oxidation number of copper became 0 and zinc became +2, right? So the
Yes, ma'am.
oxidation number for zinc increased. So this is oxidation, and oxidation number for copper reduced. So this is reduction. Okay?
Yes.
Okay. So similarly we can do the opposite. 2H2 plus O2. This goes to 2H2, which is a combination reaction. Fine?
Yes, ma'am.
Okay. Now, I am coming to a problem we faced in the last class. I gave you to determine the oxidation of number of iron in Fe3O4. Do you remember what we get?
Mhm.
Okay, no, you don't have to remember.
We got
Calculate the
8
oxidation
by
number
3.
for iron in. We got 8 by 3. But oxidation number cannot be a fractional number, right?
Yes, ma'am.
Then what is the thing with Fe3O4? What is the point in case? It's nothing. Fe3O4 is not just like Fe3O4 is not a molecule. Fe3O4 is just a mixture of FeO and Fe2O3. You see, here we have one iron, here we have two iron, here we have one oxygen, here we have three oxygen. So if we
Yes.
combine these two, we get Fe3O4. Okay. So when we say Fe3O4, we just mean that we have FeO and Fe2O3 in that. So determine the
Yes.
oxidation number in Fe and oxidation number in Fe2O3.
Ma'am, in
Determine
Fe,
first.
it is minus,
Yeah,
it is positive 2.
it is positive 2. And
And
Fe2O3 it
in,
is
ma'am, in Fe2O3, it is positive 3.
positive 3. Very good. So here it is in positive 2 and here it is in positive 3. And when combined we say it Fe3O4, we get some intermediate fractional value. Okay. The reason
Yes.
behind the fractional value is this, that Fe3O4 is not a compound, rather it is a mixture of FeO and Fe2O3. Okay.
Yes, ma'am.
Okay. Now FeO. So between FeO and Fe2O3, in which case iron has the higher oxidation number? In Fe2O3, right? In
Yes, ma'am.
Fe2O3 it is +3 and FeO it is +2. So in this case it has the higher oxidation number. So this
Yes.
we will call ferric oxide.
Yes.
Ferrous is the name for iron, okay? That is where Fe came from. So we call it ferric oxide.
Yes, sir.
And FeO we call ferrous oxide. So the point is, we will use ferrous, this suffix "as", when the atom is in lower oxidation state, and when the atom is in higher oxidation state, we will use the suffix "ik". Okay,
Yes, sir.
and it is attached to oxygen, so that's why it is oxide. That's not an issue. So what we will call FeCl2 and FeCl3. So what we will call FeCl2 and what we will call FeCl3?
Ferric chloride.
Which one? First one or second one?
First one.
First one we will call,
Ferric chloride.
in the first one, what is the oxidation number for iron?
For oxidation number is +2.
Positive 2. And in the second one, what is the oxidation number for iron?
+3.
So which one will be ferric and which one will be ferrous?
Ferric will be the second one. First one will be
Yeah.
ferrous.
So this is ferric chloride. This one will be ferrous chloride. Okay.
Yes.
Okay. Similarly, we have other compounds also. If we take example, we have Cu2O and we have CuO. First, tell me in which case copper has the higher oxidation number and in which case copper has the lower oxidation number.
More oxidation number is in. Wait. More oxidation number is in second one.
What is that? What is the oxidation number?
For first one, it is +1.
Mm-hmm.
No, it's yeah, it's +1,
No,
and
it's positive one. It's positive one. Yeah. In the second one, it is
for second one is +2.
positive 2. Very good. So this one we will call cuprous oxide. And this one we will call cupric oxide. Okay. Here it is as because of the lower oxidation state, and here the suffix is "ik" for the higher oxidation state.
Yes,
Fine?
ma'am. Yes.
Okay. Okay. Now you were asking me the name for this one, right?
Yes, ma'am.
NaClO. Okay. I give you 4 compounds. One is HClO4. Second one is HClO3. Third one is HClO2. And the fourth one is HClO. Okay.
Yes, ma'am.
Now determine the oxidation number for chlorine in the 4 cases. Okay.
Yes, ma'am.
This one, this one, this one, this one. Determine the oxidation number for chlorine in the 4 cases and let me know.
Okay. Hello, ma'am.
Yeah, you're done.
Yes, ma'am. For HClO4, I got X positive 7.
Mm-hmm.
And for the second one, I got positive 5.
Mm-hmm.
Third one, positive 3. Fourth one, positive 1.
Fourth one, positive 1. Very good.
And ma'am, for NaClO also we have to find.
Okay, try.
Ma'am, for Na,
Yes.
in that case, I found Na, so Na I assumed is as X, so I got X3, positive 3.
No, Na is positive 1. Na is positive 1, chlorine is minus 2. You have to determine for Cl, okay? So it will be plus 1, right?
Yes, ma'am, it is plus 1.
Okay. Uh, See here. Uh, Now this one, the first one, HClO4. This is known as perchloric acid. Okay.
Yes, ma'am.
The second one, this is known as chloric acid.
Yes, ma'am.
Actually, what we do, we firstly take these two, okay? We take 2 and 3. And between 2 and 3, the second one, in the second one, chlorine has higher oxidation number, right?
Yes,
So we call it chloric acid. And the third one, we call it chlorous acid. Okay?
yes, ma'am.
This we do according to our rule. We name it chloric acid and we name it chlorous acid. Now the first one is one level higher than the second one. So we call it
Yes,
perchloric acid, and the fourth one is one level lower than the third one. So we call it hypochloric
hydrochloric.
acid. Hypo.
Oh,
Hypo
okay.
means down. Hypochloric acid. Okay. So 2 and
Yes,
3 plus 5 state plus 5 state and plus 3 state, we have chloric acid and chlorous acid. And one more step higher than chloric acid, we call it perchloric acid. And one step lower than the chlorous acid, we call it hypochlorous acid.
yes,
Fine.
yes, ma'am.
Now, let's say we had this one. What we call it? Acetic acid, right?
Yes, ma'am.
Now, what is the property of acid? The property of acid is it gives H plus. So, while giving H plus, acetic acid breaks in this way. Here it gives the H plus. Okay.
Yes, ma'am.
Now this CH3COO minus, this can bond with sodium plus and it gives us CH3COO Na. Now we called it acetic acid. Now we call it sodium acetate.
Yes, ma'am.
Okay.
Yes, ma'am.
This was acetic acid and we call it sodium acetate. Now what we named it? HClO, we called it hypochlorous acid, right?
Okay,
Now
yes, sir.
hypochlorous acid would break in a way that is H plus and ClO minus. Now this ClO minus will make bond with sodium plus and it will give us NaClO. Okay, you see the
Yes, ma'am.
pattern? Then this one we will call This one was acetic acid, we call it sodium acetate. This one is hypochlorous acid, we call it sodium hypochlorate.
Yes,
Okay. Then if I try to get equivalent for all of these, like for HClO4, what will be the equivalent acetate, equivalent perchlorate for HClO4? It will be NaClO4. The next one will be NaClO3. The third one will be NaClO2. And the fourth one would be NaClO. So this one is sodium hypochlorate. Similarly, this one will be sodium chlorate. Okay.
yes, sir.
This is sodium hypochlorite. RITE.
Yes, ma'am.
Okay. Sodium hypochlorite. This one is sodium hypochlorite. This one is sodium chloride. This one is sodium chlorate. This one is sodium perchlorate. Okay.
Yes.
So this one is sodium chlorate. And this one is sodium chloride. And this will be hypochlorite. And this will be perchlorate. Okay.
Yes, sir.
Okay. So whatever we have done today, this part is clear?
Yes, sir.
Okay. So from this redox reaction chapter, only the balancing part is left. So which time will be convenient on Saturday?
Yes, ma'am.
Which time will be convenient for you on Saturday? Saturday